CG Future Composite Annuloplasty Ring. Posterior leaflet prolapse created with quadrangular resection and physiologic annuloplasty with a size 36 CG Future Composite Ring. The CG Future Composite Annuloplasty Ring is the first composite design to offer posterior remodeling while maintaining anterior flexibility. This surgical animation is created both from human anatomy and physiologic animal data. This has been combined with computer animation techniques to create a chimeric teaching model. This animation will demonstrate the repair of a posterior mitral leaflet prolapse with quadrangular posterior resection, posterior annular plication, and annuloplasty performed with a CG Future Composite Ring. The central or PT posterior leaflet prolapse is visible. This segmental defect is due to both elongated and ruptured chordae. Using cardioplegic arrest, the diseased segment of posterior leaflet is excised using a standard quadrangular resection. The defect in the posterior leaflet is then corrected with a posterior annular plication. By closing the annular defect, the cut edges of the posterior leaflet are brought into apposition. This allows them to be sewn together without any tension on the leaflet repair. The first step in performing the annuloplasty is to place trigonal sutures into the annulus. The trigones are islands of fibrous tissue contiguous with the annulus and lying medial with respect to each of the commissures. With gentle tension on the trigonal annular sutures, the anterior leaflet is evaluated for size by unfurling its edge using a nerve hook. A sizer is chosen such that its notches anteriorly match the inner aspect of the trigonal sutures. Generally, this additionally results in match between the length of the anterior leaflet and that of the sizer. In this case, a size 36 ring is appropriate. After placing the remainder of the annuloplasty sutures in the mitral annulus, the size 36 CG Future Composite Ring is brought into the surgical field. The inner half of the first trigonal suture is brought directly through the annuloplasty device eyelet. This cutaway reveals that the inner half of each trigonal suture passes through the eyelet of the ring. The second half of the suture also enters the sewing fabric from below, but is designed to exit the fabric laterally at the equator of the sewing ring. The remainder of the posterior annular sutures are likewise brought out laterally. When the trigonal sutures are tied down, this shaping device is fixed to the fibrous trigones. Pass all suture pairs through the ring and tie the sutures. You will notice that the posterior annular sutures lie lateral to the device, away from the device orifice. Post-repair function is highlighted by three important features. There's excellent leaflet coaptation as a result of the aggressive AP shaping of the CG Future Composite Ring. That means for a given intratrigonal distance, the ring provides elevation of the posterior annulus such that a ratio of the anterior-posterior height to the intratrigonal width of 1.6 to 1 is achieved. Secondly, there is preservation of the annular motion. In systole, the annulus still exhibits normal contraction with enhanced leaflet coaptation. During diastole, the mitral annulus expands, increasing orifice area and minimizing any transvalvular gradient. Finally, mobility of the anterior annulus is preserved. Note that during systole, as the annulus contracts, the anterior annulus folds up, accentuating the saddle horn of mitral annulus. This upward folding occurs in concert with the expansion of the aortic root. The aortic commissure lies in proximity just behind the center or saddle horn of the anterior mitral annulus. The resulting repair focuses on aggressive AP diameter remodeling to provide increased depth of leaflet coaptation and by permitting normal physiologic annular function.